Okay, so we're working on the first type of colligative property, which is vapor pressure. So a solution would have a lower vapor pressure than its pure solvent because the solute particles prevent the liquid solvent from vaporizing, and so you get fewer vapor molecules above the liquid. And it depends on how many particles there are. So the first thing we want to remember is what's called Raoult's law, which says that the pressure of the solution is equal to a fraction, and it's the mole fraction. We use X, and it's the solvent that we care about, times the regular pressure, water vapor pressure, or liquid, whatever the solvent may be. And so something that we have to look up here is what the water vapor pressure is at this temperature. It's not given to us in the problem. And so we're familiar with our water vapor pressure table at the end of the book. So the water vapor pressure at 40 degrees Celsius is 55.3 torr. Again, that's not given in the problem, but you do need it, so you'd have to look that up. And we know that we want the pressure to be lowered by 4.6. So if we take that normal water vapor pressure and subtract 4.6, we'll get the water vapor pressure that the solution will have, which is 50.7 torr. And so we can plug it into the equation and say 50.7 torr is the vapor pressure of the solution, which is equal to the mole fraction of the solvent, which we don't know, times the normal vapor pressure of the water, which is 55.3 torr. And so here, having two of the three variables, we can solve for our mole fraction of our solvent, of our solution, which this would work out to be 0.917. When we do mole fraction, it ends up in a decimal, and obviously it should be less than 1. We could present it as a percent, but we don't normally do that. And so again, mole fraction could be moles of solute over total moles in the solution, or in this case we have to use moles of solvent. So the mole fraction of the solvent is equal to the moles of the solvent that's there in the solution over the total moles. Don't forget the total moles. So it's moles of solute plus moles of solvent on the bottom. Okay, so we know the mole fraction. Something else that's given to us in the problem is how much water we have. So we can figure out how many moles of water there is, which is the solvent. So it's 0.5 kilograms, which we know there's 1,000 kilograms in a gram. Oops, that's not right. Okay, for every 1 kilogram, there's 1,000 grams. And then we know that there's 18 grams per 1 mole of water. And so this gives us the moles of water we have, which is 27.8 moles of water, which we have to remember is the solvent. We should always look at the problem and say, okay, what's our solvent and our solute? So our propylene glycol is the solute, and our water is the solvent. And so if we know the mole fraction, which is 0.917, and we know the moles of solvent now, the water is 27.8 moles, what we don't know is the moles of solute. And we cannot forget about the 27.8 again. So if we make a proportion and cross multiply and distribute that, we would end up with 27.8 equals 0.917 times x plus 270.8. And if we continue to simplify and solve for x, we would end up with 2.51 moles. And that's going to be the solute again, so it's C3H8O2.